In this video, we're gonna study the limit from the right and the limit from the left of a given function. But our function is in fact defined by two functions. One, when x is bigger than something, and when x is less than something. And this will help us understand what we mean when we say the limit from the right and the limit from the left. In fact, in our study here, in our case, we have f of x is x squared minus x plus 1 when x is greater or equal than 1. And we have 2 minus x when x is less than 1. So we have when x is bigger than 1, we have a function, and when x is less than 1, we have a different function. So different behavior. So what we mean when we say the limit from the right or the limit from the left. So here we are asked to find the limit from the right on this to 1, this point, on this value, x is 1. So the limit when x goes to 1 from the right. Okay, let's have the picture. Okay, so this is our value, x equals 1. So when we say the limit when x goes to 1 from the right, that means we get close to 1 from the right. We don't touch 1, but we get close to it. That means we get some values that are bigger than 1, but very close, like 1.000001. Okay, so this value is close to 1, okay, but not equal to 1. So it's bigger than 1. This value is bigger than 1, but it's close to 1 because this is very small, 0.00001. Okay, we can also choose 1.00000001. So this is another value. Okay, so here we're getting close. That means very close to 1 from the right, but not exactly equal to 1. Okay, when we say we are getting close to 1, so this is from here, this is the notation. So the limit of f of x when x is equal to 1 to 1 from the right, that means I'm getting to from this side, getting close to 1, but not exactly 1. I'm very, very close. So like I'm taking these values that are close to 1. When I'm taking the limit from the left, okay, so I'm getting close to 1, but not exactly 1. So that means 0.99999999. So this is almost 1, okay, but not exactly 1. So I'm getting from this side here, I'm getting values that they get closer and closer to 1, okay, but they will never equal to 1. Okay, so that's what I mean. So in our case here, we say this is the limit of f of x when x is getting close to 1 from the left. In our case, we have two functions. So getting from the right is using this function because x bigger than 1. So I'm getting here. So this is x. So the values, okay, let me use some. So x bigger than 1 is here. X less than 1 is in here. So when I'm using x bigger than 1, I'm going to x from the right, I'm going to use this function to evaluate the limit. When I'm using the limit from the left, so I'm in here, less than 1. Okay, I'm using this one here. Okay, so let's compute the limit from the left and see what we can get. So computing the limit from the left, so we're gonna give x some values that are close to 0, to 1, sorry, but not equal to 1, like this value. Okay, so let's say 2 minus 0.999999. So how much you get? So it's 1.000001. But this is 1, yes? So let's say this is 1. Again, let me choose another number. So I'm getting close to 1 from the left. That means I use this function. Getting from the left to 1, I'm not equal to 1 from the left. I'm less than 1, but I'm getting close to 1. it's less than 1, but I'm getting close to 1. So let's use another number. 2 minus 0.999999999. So what do I get? I get 1.000000001. This is 1. Yes. So what do we say? So the limit, okay? So in this case, we can say, we are sure now, the limit of f of x as x goes to 1 from the left. So it's 1. So this is 1. So you can say 1.00000000001. So this is 1. Okay? Think of it as you owe someone this amount of money. You're not gonna say you owe me $1.0000001. You're gonna say you owe me $1 because you ignore this. This is very tiny number. Okay, so now we're gonna use the limit from the right. So we're gonna use this one here. Okay, so here which function? The limit from the right means that I'm getting to 1 by numbers bigger than 1 but very close to 1, like this one here. Okay, so here I'm gonna use this function. So here what I have x squared minus x plus 1. When I plug this number, okay, I almost get 1 because this is like 1. So it's 1 squared minus this number, it's 1 plus 1. So what do I get? I get 1. The same thing here. When I square this number, I almost get 1. And I subtract to itself, it's like 1. And I add 1, I get 1. So what's the limit? So the limit from the right, okay, they say the limit f of x as x goes to 1 from the right is 1. So what do we say? We say the limit, okay? So once we get to 1 from both left and right is 1. That means the limit, we can say the limit as x goes to 1, it doesn't matter which way, is 1. Okay? So think of it this way. Getting from the right is getting to, let's say, let's do not 1, let's do a, okay? So let's say I wanna evaluate. So this is x equals a. So the limit of f of x as x goes to a plus. So I'm going to 1 to a from the right. I'm getting close to a, but from the right. That means values that are slightly bigger than a, like a equals x, in this case a00001. Okay, so it's still close to a. It's not equal to a, but it's very, very close to a. From the left, okay, what's from the left? How can I get, what values can I get from the left? So it's like, it's some value that are smaller than a, but very, very close to a from the left. Okay, so it's this one here. So it's a minus 0. Let's say 0.00001. Okay, so I subtract something from a. Here, think of this one as adding something to a. So it's a minus 0.00 something. So it's here. Okay. Here, think of a as a plus 0.00 something. I think you get the idea. So getting from here is getting to a, but values that are close to a, but not equal to a. Those values are bigger than a. Getting from the left, the left here, that means values that are close to a, but not equal to a, and are less than a. That's what we mean. Okay? Thank you.